In the last demo, you can see that increasing tessellation can make lighting computations look better. However, if you turn up the shininess, you can still pick out problems. Also, along the edges of the sphere, the density of the triangles is much higher than in the middle. If we keep increasing the sphere's tessellation, we'll be making a huge number of triangles along the fringe, which will cost us computation time without adding much to the final image. Ideally, what we'd like to evaluate is the reflection model each pixel. This is an entirely fine solution. Instead of interpolating the RGB values that result from computing the effects of lighting, we interpolate anything we need in the reflection model. In this case, all we need to interpolate is the shading normal. What this means on the GPU is that we have the vertex shader, we input the position and normal as before. For output, we get the screen position, and instead of an RGB computed from the reflection equation, we put a transformed normal on the output. These two normals are the vertex normals, and they're interpolated per pixel. This interpolated normal is input to the fragment shader, which then evaluates the reflection model and computes the RGB to be displayed. I should mention one important point with normal interpolation. The interpolated normals will not be normalized. That is, their length will not all be 1. As you can see in this drawing, the interpolated normals are always a bit shorter when interpolation occurs. So each normal should be normalized before using it in the lighting computation. When we interpolate normals and evaluate the reflection model at each pixel, this is called per pixel shading, or Phong shading. Confusingly, Phong invented two cool things. One was the Phong reflection model, which gives us a specular highlight, shiny spot. The other is this Phong shading, where we interpolate data across the triangle and compute the color per pixel. This is compared with Gros shading, where the color is computed at each vertex and is interpolated between those two. Try running the new demo and see how Phong shading vastly improves image quality. There's a cost, of course, in that the lighting calculations need to be performed much more frequently, but this is often what you need if you want to have a good specular highlight.